Now we're going to have a look at how to sketch some other types of functions, and we'll start off with reciprocal functions. Make sure you look over your lesson notes from what we did in class, because for now I'm just going to use these general guidelines here and go through the demonstration. Alright, so this is us trying to sketch the graph of 1 over f of x if we have f of x here. So I'm just going to try to do this side by side, and I'll try to be neat. Okay, so let's start with the x-intercepts and asymptotes, so all vertical asymptotes. So they basically swap, right? So x-intercept becomes a vertical asymptote, asymptote becomes an x-intercept, all right? So they swap. So let's just do that. So at point A, we're going to have an asymptote in our reciprocal. So that's x equals a. And where we had our asymptote at x equals k, that's now going to be an x-intercept. Alright, so now let's look at our y-intercepts in horizontal asymptote. So let's see what happens. The new y-intercept becomes 1 over b. And if our horizontal asymptote was not 0, then 1 over a is our new horizontal asymptote. So let's have a think about how we're going to graph this. So notice how b is lower than the asymptote right now. So if we inverse them, so 1 over c and 1 over b, since c has a, I guess, smaller absolute value, right? If we go 1 divided by a smaller number, it'll be larger than if we do 1 over b. Alright, so essentially what I'm trying to say is the so negative c, 1 over negative c is going to be lower than 1 over b. So let's say 1 over b is like, it doesn't matter what value b is or c is, alright? And this is going to work. So let's say that's our 1 over b, and then I'm just going to put an asymptote at y equals 1 over negative c or negative 1 over c. Okay, so that's our x's and y's sorted. Let's see what's left. No turning point, so we don't have to worry about that. And does it have a y equals 0 as a horizontal asymptote? No, it doesn't. But does it approach positive and negative infinity? Yes, it does, the original one, because it goes up that way forever, goes down this way forever, right? So that means we also have an asymptote at y equals 0 is an asymptote. Okay, so now let's figure out how to draw this thing. Alright, so if it has to pass through the x and y intercepts and approach the asymptotes, then it's going to look like this. Okay, so 1 over b, and then we have to take into account that it's still a function, but it has to also, that y equals 0 is another asymptote, so it should approach y equals 0 but never hit it. So it's going to start down here and continue this way. Alright, so there's our reciprocal function. Bit tricky, this one, lots of little things you got to look out for. The next type of function we'll look at sketching is f of ax plus b. So to sketch this one, it's kind of like reverse order of operations, right? So we actually take into account b first, and then take into account a. So what b represents is the horizontal translation. All right, so that means if we see plus b, that means it's going to the left, and if we see minus b, it's going to the right. And then let's do that first, and then we apply a horizontal stretch factor, so like thinner or wider horizontally, with a scale factor of 1 over a. Right, best to just show what this looks like. So I'll do this in a series of transformations. So draw up my axes. Okay, so the first thing I need to do, I see that my b is 3, so horizontal shift of -3, that means 3 to the left. So if those 2 points are all we've been given, then if we move shift the whole graph 3 units to the left, we'll arrive at -4 and 3, all right, because we're only moving horizontally here, and this will be our y-intercept. It'll be at 0, -5. Okay, the rest of the graph remains the same, so I'll just draw a rough sketch of the cubic function, assuming it's cubic. Now let's apply the stretch. Hang on. Put in my axes. Okay, so horizontal stretch of 1 over a. So if our a is 2, then horizontal stretch of a half, that means it's going to get compressed, if you like. So half the size horizontally. Okay, so how we do that is basically, okay, so let's have a look at our, since this is a horizontal stretch, let's look at our x-coordinates of the points we have. We have -4 and 0. So basically we halve them. All right, half of 0 is 0, so we're still going to have a y-intercept here. And half of -4 is -2, so it's going to come in a little bit. Notice how everything's horizontal. Okay, so it's just going to be a little bit thinner looking. There we go. So that stays as 0, -5. Okay, and this is so this would be f of x plus 3. Then this one would be f of 2x plus 3. And that's how we do that one. This one right here is a little bit tricky. It's a bit more algebraic. So we want to see what sequence of transformations, horizontal transformations, that means we want to go from here. So this is our f of x. We want to go to, since both transformations are horizontal, f of ax plus b. Right, let me show you how to do this. We're actually going to start with this one here. Okay, so let f of x, that's your original, that's the one we want to start off with. All right, and let's go y equals x squared takes 6x plus 9. All right, so what our goal is try to rearrange this into some form that looks like 9x squared. Okay, now the x, but instead of x, we should have a linear function. So instead of x, we want it to look like 9 ax plus b squared. That's what we're trying to get. All right, so it's a little bit tricky. Okay, so first thing, we see that this is a perfect square, right? So let's factorize this. Okay, so there's our squared. So here, keep an eye on our goal, right? It's like when we did proofs. We know what we want to try to get to. Okay, so our goal should be something like this, right? So right now we're missing, the question has told us there's two transformations. So we're missing an A and we're missing the 9. So the 9 is going to be a lot easier to deal with, or to put in right now. So how can we incorporate the 9? Well, by being a little bit creative is the answer. So we can't change the function, right? But we can do this. All right, if I do 9 times 1/9, that's still 1. Okay, so I'm going to add that in. And there we go. We haven't changed the value of our function, but we got our 9, right? So that's pretty creative. Okay, and then how can we incorporate this? So basically, we've got our 9. So now the question is, okay, what do we do with this thing? Well, we have to try to get it into the brackets, all right? Because then it'll give us this, right? So the way we do that is by using the fact that 1/9 is the square of 1/3, right? Okay, and this is just a bit of index laws, creative index laws. So if I were to break it down for you, this will give us, see how both of these brackets are squared? So that essentially means we can multiply them together and square the result. So this actually gives us, and then if we can expand what's in here, we have 9 outside of 1/3 x take 1 squared. And look at that. We have 9 bracket ax plus b squared. So, hence, a is 1/3 and b is -1. So the two transformations are in order. So 1, remember we have to go left or right first before we do the stretch factor. So if b is -1, that means two transformations are horizontal shift of 1, positive 1, or remember it's opposite to the sign, and 2, horizontal stretch of 1 over a. We saw that before, right? So 1 over a would be 1 over 1/3, which would be a factor of 3, which means it's 3 times wider that way. All right. So a lot to digest there, but that's how you can go about doing something like that. All right. Finally, this is fun, isn't it? All this graphing stuff. We want to sketch f of x all squared. So let's do it side by side again. Okay, so the main point here is if we're squaring our entire function, that means the whole function should be above the x-axis or on the x-axis or above, right? Because everything has to be 0 or positive. All right, so that's the main point we want to keep in mind. Just like the reciprocal function, let's start with the asymptotes and intercepts, right? So let's have a look at what happens. Remind ourselves. So if the original function has an x-intercept, then that intercept becomes a local minimum. All right, because of the fact that anything under the x-axis will reflect upwards, right? So this point here, A, is now, we'll keep in mind that's going to be a local minimum. And then our y-intercept will just be squared because we're squaring it, right? So b will just become b squared, but b squared is now going to be higher up here somewhere. We don't know how much it is, so we're just guessing. Okay, so b squared, and that makes sense, right? And then if x equals a, if we have a vertical asymptote, that doesn't change. So wherever k is here, approximately, we're going to keep it. And then what happens to the horizontal asymptote? Okay, you probably guessed it, it becomes squared because horizontal asymptotes are the y value. So c squared, let's just make it a bit higher. Don't know exactly where it is, don't know exactly what the scale is. So y equals c squared. Alright, and then let's try to sketch this thing. Okay, so that means any part of the graph of the original graph below the x-axis we're going to have to reflect, right? So if A is our turning point, we got our asymptotes in these spots, it has to pass through our y-intercept of B, then it has to look something like this, excuse me. Okay, and that, yep, that's not going to approach that asymptote. And anything else we need? Okay, so right, as y in the original, if y approaches positive or negative infinity, in the squared function, y is going to just approach infinity, right? So that's this bit. So see how it's going all the way down, then it's going to go all the way up like I've drawn here. So I've already incorporated that. And then what's left? Well, if we think about it, we've taken into account this side of the function, right? So what about this side? Well, remember that it's y or f of x squared. So all these are already y values. So if we square every point here, it's just going to get larger. So it's going to maybe just be a little bit higher and eventually approach the asymptotes, okay? So that is your function for this particular example, and that's how you approach graphing f of x all squared.